Hello everyone, welcome to the video series of XCAN.
So as we have covered the basic of Rust, so now what you can do is you can come onto this site modules.xcan.dev, then connect your wallet, and then you have to uh, do the GitHub authentication. So after I have done that both, so after you have done that, what you have to do is just scroll down and come to this first module, Web3 Basics. Click on Start Learning tab, and once it has 6 chapters, and once you are completing any one chapter, then as you can see this green order will be there. It marks and suggests that you have completed this first chapter. So once you are completing this all 6 chapter, you will be able to claim NFT certification directly in your wallet. So you only have to mint this certificate once you are completing this all 6 chapters, then only you will be able to mint this certificate. So as we have learned some basic concepts of Rust, so that you can now do chapter number 4 to chapter 6 of the first Web3 module, Master Web3 module. So in this module, you have to complete this all 3 chapters. So just click on Start Learning. You will have this pattern. On the left hand side, the theory will be there, and on the right hand side, the question related to that theory will be there. But as we already have covered some basic things in Rust PPT, so you can now also directly jump onto the questions, and if you are not getting the question, then you can look onto the theory or which has been given on the left hand side. Okay, so starting from why Rust, installation of the Rust, as we have also explained the structure of the Rust, variables, mutability and shadowing also we have explained. We have also explained functions. So yeah, then you can start giving the answer of the questions, like what is the primary goal of the Rust. You have to choose the correct answer. For an example, I am choosing any random answer here. Then it will let you know that your answer is correct or not. Then you have to click on the next question. In Rust variables are, then you have to complete the section. Then you will be redirected to another section. You can track your progress from here. For example, uh, in the Web3 Basics first module, we are on the fourth chapter, which is Rust Fundamentals, and it includes 3 sections. And each section will have multiple questions inside it. Getting it? So we have completed 2 questions of the first section, but now we are on the second section. So this is the second section, and we have 3 questions in the second section because we have completed first section. Okay, so just answer the question, and if you are getting any doubt and getting stuck at anywhere, then just read the description given at the left hand side. Okay. Okay, so now as we have learned some basics of Rust programming language, and let's move forward to learn some stylus concepts, like stylus core concepts, because that will be a necessary part to do the practical challenge which has been added to the stylus foundation challenge. Okay, so before jumping directly to the stylus foundation challenge, we have to understand more about stylus. Okay, so if you want to develop anything in the Web3 ecosystem, then there is a two type of thing. One is called mainnet, and second chain is called testnet. So what is the meaning of it? So for an example, you are developing any product or website which needs the smart contract developer in the backend and which is using the smart contracts, right? Then that contracts needs to be deployed on the mainnet, where if you want to deploy your contract on mainnet, and if any user wants to interact with your contract, then some gas charge will be there. What is the meaning of gas is, uh, gas means it amount that you will have to pay to interact with your contract or to deploy your contract. Now imagine what happened if you have malfunction your contract, if you have done any mistake in your contract. So for that you need to test the contract first, right? So for that purpose you have a testnet. What is the meaning of testnet? So testnet is just a kind of fork of mainnet, where you can test your contract and its working and its logic, where also gas will be required, but the gas will be also on testnet amount, means the that will not use real money, that will use a kind of duplicated money, right? So that is not a real money, But yeah, in testnet also you will have to pay some amount of gas to interact with your contract, to deploy your contract, and you test your contract, right? So for that testnet purpose in the Solidity smart contract development or any EVM compatible blockchain, you can test it using the Foundry or Hardhat, where uh, where Anvil will be there. Now, what is the meaning of Anvil? So let me give you a quick introduction of Anvil. So as you can see, Anvil versus Nitro Devnode. So Anvil is a tool which is built on Rust programming language. So it is a very fast and uh, lightweight, and it is developed by Foundry. So what Anvil do is it will simulate a local Ethereum blockchain node for you in your local environment, and it will give you some pre-funded account with some amount of ETH in it. You will get some amount in your wallet so that you can deploy your contract and test your contract in the local simulated environment, right? Before deploying your contract to mainnet, because as I said earlier, that if what if your contract have some mistakes and you have deployed it on mainnet. So before doing and developing and deploying your contract to mainnet, we need to test it and check it on testnet, right? So so we can do it locally also. So for that purpose, Anvil is used. So the feature of it is, as I already told, that it uses the local Ethereum node for simulation and testing, so that you can test the Solidity contracts, and it will purely on local development. So for the testing of EVM based contracts which has been written in Solidity, you can use Anvil or Hardhat network. But this is for the contract which has been written in Solidity language. But now we are learning the smart contract development in Rust programming language using Arbitrum Nitro technology, right? So for that purpose, Arbitrum has developed Arbitrum Nitro Devnode. So it is a similar to Anvil or Hardhat, where you are checking the development, where you are testing and simulating the development and debugging and deployment process of smart contracts written in Solidity programming language, right? Before before deploying a contract to mainnet. So same how in the Arbitrum ecosystem, they have developed Arbitrum Nitro Devnode, where you can test your contract and development which in Rust locally, right? So it's a local version of Arbitrum's layer 2 Nitro stack, which we have seen that it is a combination of EVM plus version. So where you can simulate the Arbitrum's chain locally using the Arbitrum Nitro node, so that you can interact with your contract locally, and all the transaction will be seen locally in your Docker terminal, because Nitro node uses Docker. So once you are deploying your contract or trying to call any read or write function of your smart contract, then every transaction will be seen locally in your local Docker desktop node. Okay. So yeah, so as we have seen that Nitro Devnode for Stylus contracts is just a local Devnode for testing your contract, and it will run in your Docker terminal, right? With hyphen Devnodes, which suggests for Nitro Devnode. It will have pre-funded accounts which you can use to pay the gas fees locally for testing your contract. Because as I said earlier, to test or deploy your contract on a mainnet or on testnet or locally also, you will need some funds, right? So for that, this Nitro download will give you pre-funded accounts which you can use to test your contract before deploying and testing it on mainnet. So it will have version plus EVM support, which is EVM plus, so that you can test the contracts which are written in Rust or C++ via Stylus. Okay, so it will simulate Arbitrum chain, which we have seen here. It will simulate Arbitrum chains for to test your to test your Stylus contracts locally. Writing a smart contract in Rust using Stylus, and also what is the meaning of, and also we will deep dive into Arbitrum local download. So yeah, as you can see that this is all the prerequisites which you need to do the smart contract development in Rust. So this is the Rust tool chain, ID, Docker, Foundry's cast. We have already seen this Arbitrum Nitro Devnode. So you just need to clone this repo by Opchain Labs, and go to this cd directory and simply run this script. What that will do is it will launch your dev node so that you can test your smart contracts locally on your Docker desktop. Okay. So now moving forward, creating a stylus project with Cargo Stylus. So okay, so this is important. So for example, if you want to do the development in Rust programming language, means you want to develop the smart contract, then Cargo Stylus is a tool using which you can develop your smart contracts in Rust and you can build the application around it. Okay, so as you can see that I have created one application and open it on VS Code. So now what we have to do is first make sure that you have installed all the dependencies. So as you can see that here also in first challenge, we have added all the prerequisites like what dependencies you will need to start the development in Rust. For example, Node, Yarn, Git, WSL, Docker, curl, Rust, and everything you need to install. How you can install Foundry, Foundry's cast, and all. Okay, so once you have installed all these dependencies, you can check these dependencies from here. Make sure that if you are on the Windows, then you have to use your WSL terminal to spin up the project. Just run the command cargo stylus new, and then it will automatically clone the repository for you. This is the basic starter template which you can use to develop your smart contract in Rust and build up complete project around it. So now run the command ls, cd into it, then again run ls. Then as you can see, let me give you a brief introduction of the folder structure. So inside the src, you will have two files, lib.rs and main.rs. So this is the starting point of your program, main.rs, where this is our driver kind of function, which is the main function and starting function. And this is your lib.rs, which have the counter smart contract, which has been written in Rust. So let me give you a brief overview of this contract. Like what it is doing is, so basically it's a simple counter contract. And this is the simple counter contract. So this is the impl block, means implementation block. So one struct will be there for this block. So as you can see, this is the struct for the counter, and the implementation and the functions of that will be stored in the impl block. So this is all are the functions, and as you can see that we have explained this self keyword. We have also explained this impl and struct thing in the our Rust basic chapter. So now moving forward, this is the number which to get the number which has been set by this number. For example, you have set number 5 and you will get that number here. Multiplication, addition, and basic uh, numerical operations. So now you have this contract, and if you want to test this contract locally, then you can do that using the local Nitro Devnode. So let me show you how you can do that. And this is the testing of the contract. So to test your contract, Stylus provides Stylus SDK. Okay. So as you can see inside the cargo.toml, we have features called Stylus testing, because to before deploying your contract to Sequoia also, you can test your contract without the gas fees. So if you are testing this contract and everything works fine, then you can directly jump to deploy your contract on testnet. And if everything works fine on testnet, then also before deploying to mainnet, you need to first check that all tests pass successfully on mainnet also. Then you can deploy this counter contract on mainnet. So this is the standard procedure which everyone needs should follow before deploying the contracts on mainnet. As we have seen that cargo stylus will be required, so this is how you can install it. Creating the project, you can check if your project is valid or not using this cargo stylus check command. You will get this logs after running it. Moving forward, deploying your contract. Yeah, so to deploy your contract, you can use the command cargo stylus deploy, and this is the pre-funded private key. You can see cargo stylus deploy. Then we are using the endpoint 8547. So this is 8547 endpoint is where our local Nitro Devnode is pinning. So at our local Docker desktop. Okay, so Nitro Devnode will spin up at your 8547 port at your Docker desktop. Don't worry, we will see the visuals of it also, like how this will be done, and what if you are running this command, and if you are running this command, then how you will see the transaction in the Docker terminal. Okay, so once you are deploying this, we are estimating the gas, like how much gas will be required to deploy this contract. And the private key is the pre-funded accounts private key. Endpoint means where we have to deploy our contract. So we are currently deploying to Arbitrum Nitro Devnode. Once you are deploying it, you will see this kind of information. Let me show you. So as you can see, this type of information will be shown to your Docker desktop terminal. Like first compile and debugging will be there. Then you will see this transaction hash and contract address. So this is the contract address of the contract which you have deployed. Okay. So now moving forward, this is how you can export the ABI for the smart contract written in Rust Cargo Stylus export ABI, and then it will return the ABI in this manner. So make sure that this ABI will be required to interact with your contract from the front end, right? Okay, so to interact with your contract, Foundry's cast tool will be used. So what is cast is, as you can see, this is the syntax of it. Let me explain you the basic syntax. So cast call RPC URL. RPC means where you have deployed your contract, at mainnet or at Sepolia or at local Nitro Dev node. So as we have deployed our contract on local Nitro Dev node, we are using that URL. Like we have deployed our contract on at this address. Now we want to interact with that contract function. So this is the RPC URL we have to add. And the private key is, why this private key is required? Because as I have said that if you want to perform any write operation, then you will need some gas fees. For example, if you want to set number, multiplication of number, you want to increment number, what add number, if you want to perform any operation from this, then these all are the write operation, and for this gas will be needed. If you are doing only read operation from the blockchain, then the gas won't be needed. Okay, so that we are using the private key, so that if the gas is required, then that will be cut from this private key which is pre-funded. Then we are using then we have to pass the deployed contract address, which you can get from Docker terminal like this. Okay, then you have to pass the function signature which you want to call. For example, we are trying to call the this number function. We have passed the signature of it, and then it will return 0, because by default the number will be 0 in Rust. Okay, for example, now if we want to increment the function, as you can see, then we have to use this, and the increment signature, we have to pass the function signature for increment, and this kind of transaction will return. Okay, so this is the gas cost, how much gas has been used from the pre-funded account. This is the pre-funded account's address, and this is the private key for the pre-funded account. So as we have seen that to test your contract, you can use this, and inside the features you will have Stylus test, and then you can run your test using Cargo test. So this is how you should be using the Cargo Stylus CLI tool to develop your contract. You can also verify your contract using the Cargo Stylus, and you can also export the ABI using the Cargo Stylus tool.
Yeah, so that's all for this video. If you have any doubt, then please feel free to reach out to us. Thank you everyone.